tutorial, I'm going to teach you how you can use Qiskit to implement your own circuits in the processor of IBMQ. The first is import IBMQ from import Qiskit as QK, and the first thing that you should do is create a circuit, and for this you need three things. The first thing that you need is your input. Your input are the qubits. Those qubits are in the zero state at the beginning, and you have to process all of this, the information of these qubits, with applying some gates, and after you are going to have some result. Then you have to define qubits, QK, quantum register, and here you put the number of qubits that you need in your experiments. In this case, it's just we are going to do a superposition state, then we just need 1 qubit. The second thing that we need here is to define the output, and after we create the circuit, we can implement all the gates or the intermediate steps in our circuit. Then we can define just output here, QK, classical register, and we are going to say that we just need one classical register. That means that we are going to just to use 1 qubit and register all the information in just 1 classical register or 1 channel. And now you can create your quantum circuit, and just your circuit is going to be QK quantum circuit, and we need two things here. The first is the input, that means the qubits, and the output, that is where you are going to measure. Once you have done this, next you can see how your circuit looks like, just applying draw an MPL here inside to see the circuit in a fancy way. Okay, we don't have anything inside our circuit. We are not applying any gate in this moment. Now we are going to put inside our circuit a Hammadar gate. This gate is transforming my zero state in a superposition state. Then we just have to say in which qubit we want to apply this gate, and it's going to be in the qubit 0. Once we are done this, we can just show again our circuit. And that's it. We have now the Hammadar gates applied to qubit 0. But the thing here is that we need to measure after we apply those gates. Then we just say circuit measure, and we are going to measure our qubit 0 in our output 0, and we can see how is our circuit looking now. Okay, now after applying a Hammadar gate, we are going to measure, and next we need to create an account or having an account in IBMQ. If you don't have an account, I'm going to give you in the description of this video how you can get an account of IBMQ to implement in a real device. But here I already have an account, Then I just have from qiskit import IBMQ, and I'm going to define my provider. This is with IBMQ load account, and just because I have already my account, I can execute this, and now I have a provider. And for looking for the back ends that are available for me, because I have my account, I have to look for the backends that I have available. Then backends are provider, backends, and to save all the names, just we are going to create a list. At the back or I'll list each of the names. Then is backend, name, and that's it. If we plot the names, we are going to see all of these processors available. Some of them are just 5 qubits. For example, this is 15 qubits, and this is 1 qubit, but it has a special ability that you can work directly with pulses. First, I'm going just to simulate this, and after I'm going to use one of the real devices to implement this circuit. First, we have to create a backend, and this is just provider get backend, and we have to put the name. Then I'm going just to simulate in this time what is happening. Once we have the backend, the next thing is execute the job. Then is qk execute, and here we have to define the circuit. After the backend and the number of shots that we want to apply. In this case, I'm going to do 1000 different experiments to get the probability of getting the state 0 and the state 1. In this case, as we have an ideal case, because we are simulating this, we are going to find that we almost are going to have the same amount of result in the 0 and in the 1s. Okay. Sorry, here is shots. Okay, we already execute the algorithm or my circuit, and now I'm going to show the results. The result is just job result and get counts. And with this, we have the results, and we can use a tool from qiskit visualization. I'm going to extract plot histogram. And we can look for the results as plot histogram result. And that's it. We have the results based on an ideal case. This is going to be really close to 50% in 1 and 50% in 0. But what happens if we try to change our backend to a real device? For example, I'm going to use qiskit-IBMQ x2 provider, get backend, and the name of IBMQ x2. Job 2 QK execute circuit backend and shots 1000. Result 2 is gonna be job result and get counts. Plot histogram result 2. Sorry, here is job 2. And here we can see that we have more variation than before, and this is just because in a real device you are going to find noise in your circuit and you are not going to have 50% like in the ideal case. Okay guys,